Alright, and finally we've made it to part 4. We're going to talk about use versus availability, and this is really where it gets, I think, kind of fun, because we're going to take all of the stuff that we've done and actually make some sense out of it and create a preference ratio. So, what am I talking about with use versus availability? The idea is that we have these home ranges now, right? We can extract information about the landscape and compare what's available to the animal against what the animal seems to be actually using. So if we have 100 observed locations, for example, for an animal, and make the assumption that the animal is using its home range evenly, we would expect all of the observations, all those 100, to be evenly distributed among the home range area. So what if we were to look at the land cover and found that half the home range was covered in wetlands and half was covered in grasses equally? If the animal had no preference for land cover, then we would expect 50% or 50 points of those 100 observed locations to be in wetlands and half of them to be in the grass. But what if we actually found that only 10 of the locations were in the wetlands and 90 of those 100 were in the grasses? We have a disproportionate use versus what's available. The animal is being observed in the grasses more than we would predict or expect the animal to be in the grasses. So that's a super simple explanation or example, but that's exactly what we're going to end up doing, is trying to predict, given an even distribution of those observations, we're going to take a look at what's available to each animal and then predict where we would expect them to be given the proportion of the land cover type. Yeah, and then I'll talk to you in more specifics about what a preference ratio is at the end of this. But just remember that we have this land fire data that has a description of all the land cover types, but there's a raster value, which is a number, which is a code for each one of these narrative descriptions of the land cover type, and you're going to have to use that code. So the availability is summarized using the habitat, right? So we're going to clip the land cover using a home range, and then what's used or utilized is, instead of looking at that zone, we're going to look at the locations of the actual point. So instead of taking this generic area and saying, okay, this is what's available in their home range, where are they actually found? And actually is in quotes because we know that there's some uncertainty with these locations. But we're going to just go ahead and plug them in their exact location and say, okay, here's what's actually getting utilized. So we're going to use a tool called extract value from point, where it just drills down at every location of the point to the land cover raster and assigns that land cover raster to the point location. Okay, so just one more time. What's available to the animal? Take the home range and we're going to clip the land cover raster. And then we're going to go in and look at the count field. Remember, with rasters, what we get is a count. So let's say whatever this tan thing is, maybe it's playa. Maybe there's 20 out of 100 cells in this land cover are in playa. We're going to look at that count field and calculate a proportion of the total. So we're going to, here, let me show you this screen here. So here's our clipped land cover. We have the different counts. You can sort that, and so we could look at this very top one, the highest one, and say, okay, this is the largest proportion of this home range is this land cover type, whatever it is right here. But what we're interested in is the proportions. So I want you to take the count field and then right click and go to the statistics and look at the sum and get the sum. And now you can either do this in Excel, you could export this table, or you could just type everything over into Excel, but it'd be much faster to export it. Or you could make this calculation right in ARC by adding a field, and doing a field calculator and dividing the count by this total, the total number of cells. Now it would also be smart if you wanted to evaluate, you could take this sum and multiply it by the area of one cell and calculate the area of the land cover, or sorry, the home range, and just make sure that that's correct. That would be one way to self-evaluate. But you want to put the total number of cells in and divide the count by the total to get the proportion. Okay? So that's going to give you the available. Now for the used, we aren't interested in this area anymore. We're only interested in the points, and we're interested in what land cover is coincident with the point. So you're going to use this tool called extract values to points. It outputs a new point shape file with the attribute of the raster at that location. Now the tricky part of this is that that's not a very easy thing to summarize, but I'll demonstrate that in 1 second. So we're going to look at the total number of observations, and then we want to calculate the expected observations in the available land cover, and then finally you're going to calculate a preference ratio. So it might look something like this. This is a totally made up animal, very simplified. But let's say in our land cover we have our home range for our animal, and we clipped the land cover down and we ended up with 3 land cover types that were represented. The cell counts were as follows: 10 of them were grass, 30 of them were urban, and 20 of them were wetland, for a total of 60 cells. Then we can calculate the proportion. We can divide 10 by 60 and we get 0.2, 30 divided by 60, 0.5. Okay. So this is the proportion you should test. Make sure it equals 1. Now, for the used, we had 105 observations. We had 105 radio color, point locations or whatever it is. And we extracted the value to the points. 90 of the points fell within grassland, in the grassland cover. 12 of the points were urban and 3 were in the wetland. Okay, that's fine. We're going to do the same thing and calculate the proportion. We want to know, what proportion are each of these. Now, I'm going to have you calculate what we would expect to see, and what we want to do is kind of compare where the animals were really found versus what we'd expect to see if they were evenly distributed, and they showed no preference for any kind of land cover type. So what you're going to do is you're going to multiply this proportion, whoopsie, not like that, you're going to multiply this proportion by the total count. So we have 105 known observations. This is what we'd expect to see, because this is 20% basically of the total home range is grassland. So multiply 105 by 0.2 and we'd expect 21 of the observations to be in grass. Now we actually saw that 90 of them were. So we have an they're overutilizing, they're preferring grass. If we multiply 0.5, the proportion is half urban of this home range. We would expect half of our observations to be there, but we are finding that there was only 12 out of the 105 were in urban. So we're underutilizing that land cover type, right? So this gives us a kind of qualitative look at it, and it's a good way to be able to evaluate this ratio. We're expecting 21. We actually saw 90 of the observed locations were in grass. Okay, does that make sense? And then what you're going to do here, the selection ratio doesn't deal with this as much, but it should reflect the same thing. What you're going to do is divide the proportion of the used by the proportion of the available to get this selection ratio. And any preference ratio greater than 1 means that that's a preferred habitat. So you can see here, we saw, what we observed is that 90 of the 105 were in grass. We expected only 21, so that they're using it more than we would expect them to. So it has a very high selection ratio. Whereas here, we expected them to have 52, there were only 12. It's less than, and so we have a value less than 1. And here, 3 out of 105 just doesn't quite register. Mostly because I set my precision very low, but I think that's reasonable considering how precise those locations probably are. So this is what you're going to set up. You're going to calculate what we would expect, and then you're going to calculate a selection ratio, and these two things should be coincident. The used versus expected and these should agree with each other. Okay, so the trick with ArcGIS, hang on 1 second. Alright, the trick with ArcGIS is that when you run the extract values to points tool, you input your coyote point locations and the land cover, name your output, and then I tried appending all the input raster attributes to the output, and it just didn't work. I'll show you what it looked like. So if you don't do that, what you end up with is an attribute table. So this is my land cover at the locations of Coyote 07, and it outputs all the attributes that came in with the Coyote, but at the very end you get the raster value. And so what you end up having to do, I just sorted this so that they were organized, is you have to go through and say, okay, there were, whoopsie, not that many. Okay, so I selected all the 11s, so there were 5 out of 76 that are raster value 11, and then open the land cover and find raster value 11. And so you just kind of have to manually put in. So 5 out of the 76 were in Intermountain Basins active and stabilized dune. You have to toggle back and forth like that. What I tried to do is append the entire land cover attribute table to the CO7, and it didn't work. And I'm not sure if this is a 10.4 glitch or if it's my computer. I'm not going to sit here and try and figure it out right now, and I don't expect you to either. Oh great, now I'm all hung up. Oh, for goodness sakes. Well, anyway, I just got a bunch of gobbledygook at the end, and it wasn't the correct attributes. So you can mess around with that if you want. It's not a big data set. If you were trying to do this for thousands of animals, then we're going to have to run into automating this with some Python scripting. But we're just doing one animal. You can go ahead and manually plug this into an Excel table or however you want to do this. But that's what you need to do, is summarize those land cover values and calculate the proportion that way. So if you have any questions, let me know, but that's really it. Let me just double check here. Yep. So that's it in a nutshell. Questions, let me know, and if not, thanks for your time.